calculus students. In this video, you must learn to look within yourself for this next rule of derivatives. And that is why I am, before I teach you this, looking within myself. And I am ready. I have looked within myself, and I'm ready to help you look within yourself. So let's get to it. Here we go. This is the chain rule 5-2-1. Look within is the key here. And this, just like the last video on the product rule, is just as important, where you will be using this quite a bit. And believe it or not, you've already been using it in a way. So here we go. I need to adjust my settings. So the chain rule, and what it says is, for a function, rule is if you have a function f of x, which is equal to a composition of functions, so say g of h of x, then what the chain rule says is that when you take the derivative of that function, it's the derivative of the outside, leaving the inside alone, times the derivative of the inside. And that's the chain rule there. Now in words, it's saying this, that the derivative of the outside, leaving the inside alone, let them be. Just like, I should tell my dog, let them be. The derivative of the outside, leaving the inside alone, times the derivative of the inside. And that is the chain rule, where you have to look within to know what the inside function is. Now, I'm going to say it a few times, and I encourage you, as awkward as this might be, whether you're in your living room, your bedroom, and it's 1 a.m., or maybe your sibling is sleeping across from you, say it out loud, make them hear it, and they'll be learning calculus with you. The chain rule states the derivative of the outside, leaving the inside alone, times the derivative of the inside. And right here, I'm going to pop it up to my text box to my left. The derivative of the outside, leaving the inside alone, times the derivative of the inside. And we'll say it one more time. The derivative of the outside, leaving the inside alone, times the derivative of the inside. That is the chain rule. And it is so useful, as it's going to help us solve so many derivatives. So let's look at several examples of how this works, where we're going to look within and find that function. So the first function we're going to look at is f of x is equal to cosine of x squared. Right? And then we'll look at f of x is equal to 3x minus 1 to the 5th. And we'll look at f of x is equal to the square root of 9 minus x squared. And lastly, we'll look at one that we've done quite a bit, and you know how to do previously, but we're going to look at just x plus 3 squared. So here we go. So in this first one here, the derivative of this function. Now, what is the inside? The inside is the inner parentheses here. It's cosine. Imagine cosine being the outside and x squared being the inside. So it's the derivative of the outside. So the derivative of cosine, which the derivative of cosine is negative sine, leaving the inside alone. So leaving that x squared, let them be peaceful, let them live their life, times the derivative of the inside. So what's the derivative of x squared? Well, that's 2x. And there's the derivative of that function there, negative 2x sine of x squared. Awesome. All right, let's look at the next one. So now we have 3x minus 1 to the 5th. You might be saying, well, where's the inside? Well, this is the inside right here, and the outside is raising this function to the 5th power. So the chain rule states here that the derivative of the outside, so we have a polynomial, say, this is a function g of x, that's all being raised to the power 5th, so it's going to be 5, leaving the inside alone, so leaving that 3x minus 1, and then we minus 1 for polynomials, times the derivative of the inside, so the derivative of 3x minus 1 is 3. So this actually gives us the derivative of 15, 3x minus 1 to the 4th, and there's the derivative of that function there. Now we look at this function here, f of x equals the square root of 9 minus x squared, where the square root is on the outside and then 9 minus x squared is the inside. So if we take the derivative here, well, maybe this one what I like to do, and I think a lot of you are doing this too, is I like to write square roots as exponents. So let's write this as 9 minus x squared to the 1/2. And now we can apply the chain rule, where it's the derivative of the outside, where we bring that to the front, and minus 1. So then we get negative 1/2 times the derivative of the inside, which is the derivative of 9 minus x squared, where the derivative of 9 is 0. The derivative of negative x squared is negative 2x. So what we get there, if we put it all together, is f prime of x equals negative x over 9 minus x squared as a square root, because it's to the negative 1/2 power. And that's great. Now, let's look at this one over here. I'm going to bring this one down. Now, we've done this in the past. We've looked at f of x equals x plus 3 squared. And in the past, what you would have done is you would have said, okay, f prime of x will equal 2 times x plus 3 to the first, and you would have been done. That's what we've done in the past. And in fact, you're not wrong. We just never really taught you the chain rule yet. What is the chain rule? Where if we do it with the chain rule, notice how we get the same thing, just like we did here with 3x minus 1 to the 5th, where you're going to get the derivative of the outside, so we bring that 2 to the front and subtract 1, leaving the inside alone, leaving that x plus 3, times the derivative of the inside. But what's the derivative of x plus 3? The derivative of x is 1, the derivative of 3 is 0, so it's just times 1, which that doesn't change anything, so we actually still get that same thing we're used to. So notice that you've always had the opportunity to do the chain rule, but the problems we gave you, the reason your derivative always worked is because of that case there. We always had it times 1. But really, you should have been applying the chain rule since the beginning of the year. We just had the book, and I had to be very careful about giving you problems that would not do that. All right, so there it is, the chain rule. I'm going to say it one more time just to annoy you and help you keep it in your brain. It's the derivative of the outside, leaving the inside alone, times the derivative of the inside. Emphasis on that word leaving. Leaving. You want to do that. Make sure you don't forget that part. All right. Hope that makes sense. Let me know if you have any questions. Bye-bye.